All right, totally overdid it on example 8. It asks to find R. So I didn't have to solve for a sub 0 or the general form. Okay, continuing on to 8. Determine the following sequence's arithmetic progression. If not, identify the common difference. If it is, answer D and E. All right, so we are just looking for the differences, and if they're the same through all 4 numbers, and it looks like they are, it's all, each pair of numbers is going down by 5. So it is an arithmetic sequence, and you're going to check yes on the quiz, and you're going to say D equals -5. Yay for a simple problem. Okay, same idea, only we're going to look and see if it's a geometric progression. So here's how you tell if it's geometric. I would just, so this gives us n equals 0, 1, I don't need the commas, 0, 1, 2, 3. So we know a sub 0 equals -4. And our geometric, our general form, a sub n equals a sub 0 r to the n. If we can see that with the next 3 numbers that we have the same base to our exponent, then we're in good shape. So let's take a look at a sub 1. That's going to be -4 times r to the 1 power. So if I fill in the 16 they give us in our list, I get -4 r to the 1 power. I'm not going to write that. This lets me solve for r. So it looks like not only is a sub 0 -4, but r is also -4. Let's see if that happens with a2. So is that going to be equal to -4 times -4 squared, and they give us a sub 2 is -64. -4 squared gives me 16. -4 times 16 is definitely 64. And we can be fairly confident. They're not going to give us, in my opinion, I don't have to check the last one. They're not going to give me 3 in a row. And it looks like the last one is growing by the same exponent. So our common ratio here is -4. We click yes. Okay, on to a couple of applications. So they give us this problem. We've seen this similar problem before with exponential functions, and this is definitely an exponential function. So a crane sells for $600,000. After that, the value decreases by 20% each year. We can use a geometric sequence to find the value for the crane at the end of each year. If we let a sub 0 represent the value when it's purchased, then a sub 1 is the value after 1 year, a sub 2 is the value after 2 years, and so on. So write the first 5 terms of the sequence, starting with, got to count my zeros, there's 5 of them, starting with the original price. Okay, now, to determine the price, how much it lost value, it's going to lose 20% value, so I could multiply that by 20% and do some subtraction. Easier, though, is decrease by 20%. So 100% minus 20% is 80%, so it retains 80% of its value each year. So throwing in some math here, take my 600,000, I'm going to leave some room here. So 600,000 times 0.8 gives me the value at the end of the first year, which is $480,000. Now, I'm going to take the $480,000, I'm going to multiply that by 0.5, that 0.8. That'll give me the value after the second year. That turns out to be 384,000. And continuing with this idea, 384 times 0.8, that'll give 307,000. 200. Okay, so listing these out. Those are the first 5 terms in the sequence. Common ratio is the thing that's under the exponent, the base of the exponent. And the sequence, the recursive sequence, so we have a sub n. That's the initial price of 600,000 times r to the n. 600,000, sorry. And the base of my exponent is 0.8. And we are done with that problem. Okay, I'm going to try to squeeze this last one in. Rocket travels vertically 3,200 feet in its first second of flight, and then about 30 feet less each succeeding second. Write a sequence of the vertical distance traveled by the rocket in the first 6 seconds. So, here's the thing. It's going to travel 3,200 feet in the end of the first second. So that means n equals 1 here. And then it's going to go down. So the second term is going to be 3,200 down by 30 feet. And that gives 3,170. Third sequence, I'm going to go down 30 feet again. Fourth, go down by 30 feet. And the fifth, so the first 6 seconds, second 1, 2, 3, 4, 5. N equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So we go down by another 30. So 3080, and then n equals 6, 3050. Okay, what kind of sequence is it? Arithmetic or geometric? Look, it's going down by 30. That makes it every time, so that makes it arithmetic. Give the general rule for the sequence, a sub n. So a sub n is going to be equal to a sub 0. Times a sub 0 plus dn. So it's going down by 30. But here's the thing. Our counting is off by 1. And this threw me off on the quiz, by the way, so I want to make sure that you don't have that same thing happen. A sub n, notice we started at n equals 1. And so we expect that, so a sub 0 is going to be, the way that we're working this is actually to use a sub 1 instead of a sub 0. So we're going to start with 3,200. We're going to go down by 30, and then it's going to be n minus 1 here. And we're done with that lesson. I'll see you in class.